Hello aspirants, welcome back to my YouTube video. Today I am going to discuss geometry versus shape. Geometry and shape, as we discussed in the last video, that are not always equal. If the lone pair in the central atom is 0, then geometry is the shape of the molecule. But if the lone pair is in the central atom is not 0, then the geometry is not the shape of the molecule. Here I will be taking some examples. So first of all, let's understand that what is geometry and why it is different from the shape. So for geometry, we see both the lone pair as well as the bond pair in the molecule. But in case of shape, we only check the bond pair, means after you draw the structure including lone pair, hide the lone pair and observe the shape. Now we will be seeing different types of molecule. Here the different types of molecule are, the first one is AB2 type. What is the meaning of AB2? As above I have written these things, that B will be referring to the bond pair. In the first question we have AB2, which means that there are two bond pair, no lone pair and a central atom. So we will be abbreviating the bond pair as B, the lone pair as A, and the central atom as A. The lone pair as L and the central atom as A. Let's move further. First molecule is AB2 type. Here there are two bond pairs, so we'll be structuring or arranging them as linear, and here are zero lone pair, so the shape will be equal to the geometry, that is linear. Moving on to the next one. The next one is AB3 type. In AB3 type we have three bond pairs and no lone pair, so we'll be arranging it like this so that there is minimum repulsion. As we have discussed in the geometry that how to draw the geometry, you can check in the description. I have given the link of that video in which we have discussed how to see the geometry or draw the geometry of any molecule. As we see here, again the lone pair is 0, so the geometry is equal to the shape, that is trigonal planar. Moving on to the next one, that is AB2L type. Here there are two bond pairs and one lone pair. So as I have told you that we will hide the lone pair for in case of the shape. So here the geometry is trigonal biplanar, but in case of shape, let's hide the lone pair. Then we will observe the shape, which is here bent. See this in this is a bent shape. Next, moving on to AB3L. Here three bond pairs and one lone pair is there. Again, hide the lone pair and observe the shape, that is trigonal bipyramidal. In the next case, there is AB2L2, means two lone pairs and two lone pairs and two bond pairs. So we will hide the lone pairs to get the shape once again, and let's observe the shape. The shape is like this. Again, this is a bent shape as in case of the third molecule. Moving on to the sixth one. The sixth one says four lone pairs and four bond pairs and one lone pair. So let's hide the lone pair and we'll observe the shape, that is seesaw like shape. Moving on to the next one, that is AB3L2. AB3L2 means three bond pair and two lone pair. Let's hide the two lone pairs and the shape we will get is T shape. The next one is AB2L3. Again hide the lone pairs you will see the shape as linear. Now the next one is AB5L, means 5 bond pair and 1 lone pair. Let's again hide this lone pair. We'll observe the shape as this square, and from top of it one pyramid is there. So this is square bipyramidal. The last is AB5 AB4L2, means 4 bond pair and 2 lone pair. Let's hide the lone pair. We'll observe the shape, that is on a square there are 4 bond pairs. So this is a square planar. So this was so easy to see what is the shape, and this will be applied on all the molecules in universe except some exceptions. So thank you. If you like the video, please hit the like button, subscribe to my channel to get the latest notification or to get such videos, and get hold of the subject very easily. Thank you.